A short video on TCP. By Arvind Ka. TCP stands for Transmission Control Protocol. It is a connection-oriented protocol. It provides a reliable unicast end-to-end byte stream over an unreliable internetwork. Before any data transfer, TCP establishes a connection as follows. One TCP entity, server, is waiting for a connection. The other TCP entity, client, contacts the server. The actual procedure for setting up connections is more complex. Each connection is full duplex. Byte stream is broken up into chunks which are called segments. Receiver sends acknowledgements, ACKs, for segments. TCP maintains a timer. If an ACK is not received in time, the segment is retransmitted, detecting errors. TCP has checksums for header and data. Segments with invalid checksums are discarded. Each byte that is transmitted has a sequence. Byte stream service. To the lower layers, TCP handles data in blocks, the segments. To the higher layers, TCP handles data as a sequence of bytes and does not identify boundaries between bytes. So, higher layers do not know about the beginning and end of segments. TCP format. TCP segments have a 20-byte header with greater than 0 bytes of data. TCP header. TCP header fields. Port number. A port number identifies the endpoint of a connection. A pair, IP address, port number, identifies one endpoint of a connection. Two pairs, client IP address, server port number, and server IP address, server port number, identify a TCP connection. Sequence number, SECNO. Sequence number is 32 bits long. So the range of SECNO is between 0 to 232-1, which is nearly 4.3 gigabytes. Each sequence number identifies a byte in the byte stream. Initial sequence number, ISN, of a connection is set during connection establishment. Question: what are possible requirements for ISN? Acknowledgement number, ACNO. Acknowledgements are piggybacked, that is, a segment from A to B can contain an acknowledgement for a data sent in the B to A direction. QSN, why is piggybacking good? A host uses the ACNO field to send acknowledgements. If a host sends an ACNO in a segment, it sets the ACK flag. The ACNO contains the next SECNO that a host wants to receive. Example, the acknowledgement for a segment with sequence numbers 0 to 1500 is ACNO equal 1501. Acknowledge number, CONT-D. TCP uses the sliding window flow protocol to regulate the flow of traffic from sender to receiver. TCP uses the following variation of sliding window: no NACs, negative acknowledgement, only cumulative ACKs. Example: assume, sender sends two segments with 1500 and 1501, 3000, but receiver only gets the second segment. In this case, the receiver cannot acknowledge the second packet. It can only send ACNO equal 1. Blank. Header length, for BITS. Length of header in 32-bit words. Note that TCP header has variable length, with minimum 20 bytes. Flag bits. URG, urgent pointer is valid. If the bit is set, the following bytes contain an urgent message in the range. SECNO, less than equal, urgent message, less than equal, SECNO plus urgent pointer. ACK, acknowledgement number is valid. PSH, push flag, notification from sender to the receiver that the receiver should pass all data that it has to the application. Normally set by sender when the sender's buffer is empty. Flag bits. RST, reset the connection. The flag causes the receiver to reset the connection. Receiver of a RST terminates the connection and indicates higher layer application about the reset. SYN, synchronize sequence numbers. Sent in the first packet when initiating a connection. Fin, sender is finished with sending, used for closing a connection. Both sides of a connection must send a fin. Window size. Each side of the connection advertises the window size. Window size is the maximum number of bytes that a receiver can accept. Maximum window size is 216, 1 equals 65535 bytes. TCP checksum. TCP checksum covers over both TCP header and TCP data, also covers some parts of the IP header. Urgent pointer. Only valid if URG flag is set. Options. NOP is used to pad TCP header to multiples of 4 bytes. Maximum segment size. Window scale options. Increases the TCP window from 16 to 32 bits, that is, the window size is interpreted differently. Q. What is the different interpretation? This option can only be used in the SYN segment, first segment, during connection establishment time. Timestamp option. Can be used for connection management in TCP. Opening a TCP connection, closing a TCP connection, special scenarios, state diagram. TCP connection establishment. TCP uses a three-way handshake to open a connection. 1. Active open, client sends a segment with SYN bit set, port number of client, initial sequence number, I. 2. Passive open, server responds with a segment with SYN bit set, initial sequence number of server, ACK for ISN of client. 3. Client acknowledges by sending a segment with ACK ISN of server. Three-way. A closer look. Three-way handshake. Why is a two-way handshake not enough? When IATA initiates the data transfer, starting with SECNO equal 15322112355, MNG will reject all data. TCP connection termination. Each end of the data flow must be shut down independently, half close. If one end is done, it sends a fin segment. This means that no more data will be sent. 4 steps involved. 1. X sends a fin to Y, active close. 2. Y acks the fin. At this time, Y can still send data to X. 3. And Y sends a fin to X, pass. 4. X acks. Connection termination with TCP dump. TCP connection. TCP states. State description closed. No connection is active or pending. Listant server is waiting for an incoming call. SYNRCVDA connection request has arrived. Wait for ACK SYNSENT. The client has started to open a connection. Established normal data transfer state. FIN wait 1 client has said it is finished. FIN wait 2 server has agreed to release. Timed wait for pending packets. 2 MSL wait state. Closing. Both sides have tried to close simultaneously. CLOSC wait server has initiated a release. Last ACK wait for pending packets. TCP states in normal connection. TCP state transition diagram open. TCP state transition diagram closing a connection. 2MSL wait state. 2MSL wait state equal time_wait. When TCP does an active close, and sends the final ACK, the connection must stay in the time_wait state for twice the maximum segment lifetime. 2MSL equal 2* maximum segment lifetime. Why? TCP is given a chance to resend the final ACK. Server will time out after sending the FIN segment and resend the FIN. The MSL is set to 2 minutes or 1 minute or 30 seconds. Resetting connections. Resetting connections is done by setting the RST flag. When is the RST flag set? Connection request arrives and no server process is waiting on the destination port. Abort, terminate, a connection causes the receiver to throw away buffered data. Receiver does not acknowledge the RST segment. Thank you.